This is lesson 7-6 Math 121, adding integers. So you might remember, or you might not, that an integer is defined as all the counting numbers, their negatives, and 0. So really anything on the number line, 0, 1, 2, 3, 4, 5, 6, -1, -2, -3, -4, -5. And it goes infinitely in the negatives and infinitely in the positives. What it doesn't include is things that are between the numbers, like between 0 and 1, there's the number 1/2 and 2/3. Those are not integers. So we're practicing adding integers, which is sometimes adding negative numbers or adding a negative number to a positive number. Or even when you add two positive numbers, you're still adding integers. They were showing you as an example a thermometer, because we know that the temperature can go below 0. So if 0 were over here, -5, -10, and we go up by 5s, we know that if we start at 20 degrees and if the temperature drops 25 degrees, we drop 5, 10, 15, 20, 25. We drop to -5 degrees. So it's just like on the number line. Another way to think about adding integers is using Legos. So it's a good reason to get out some Legos. I chose two different colors. So with my color scheme, the red means negative number and the white means a positive number. So what happens is, suppose you wanted to add -3 plus 2. So when they pair up, you can get rid of them. It's like they destroy each other, or maybe they eliminate one another, or they get sucked into a black hole together, something. So when they can pair up like that, you remove them. And we're left with -1. Okay, try it a different way. What if you had -3 and +3? So they'll pair, and all of them will go away and you're left with 0. Or if you had something more like -3 and +5, you can only pair up 3 of them. And those go away, and you're left with +2. Okay. And what if it's another, like a larger negative number, -3 and -1? These two go away and you're left with -2. So Legos or Unifix cubes are a good way of kind of thinking about these numbers until it gets a little bit easier. On example 1 in your book, they have us diagram +8 plus -5. And right now, they're putting a plus in front of that, but they don't always have to do that. If there's no sign in front of it, just assume that it's positive. So the way we need to do these numbers is, I'm going to need to number it a little bit further. We start at 0. Always we start at 0. So that will be 7 and 8. We start at 0. And the +8, when it's positive, you move to the right. When it's negative, you move to the left. So +8, we're going to move 8 to the right, and that will end us up over here. And we draw an arrow to show the direction we're traveling. So we start at 0, and we travel to the right, 8. Then we're going to subtract 5. We're going to move up a little bit, and because it's a negative, we're going to move 5 to the left. So that will be 1, 2, 3, 4, 5. We're going to end up here. Draw that line and show the direction we're traveling with an arrow and go straight down, and that's our answer. So +8 plus -5 equals +3, or just 3 if you'd like. If we have another example, example 2, in this case, they're going to add two negative numbers. They're adding -5 plus -3. Oops, move it over here. Another way to think about integers, at least what I like to think about sometimes, is money. Like this is money you owe because it's negative. So if you owed somebody $5 and then you're owing them 3 more, you're going to owe them $8 in the end. Like here, if you had $8 and you owed somebody 5, once you pay them off, you only have $3 left. So this example, we start at 0 again. Oh, we start at 0. And we're moving 5 to the left because it's negative. We'll wind up here, and the arrow is going to go to the left because that's the direction we're traveling. We move up, and we're moving 3 more to the left because it's still negative. 1, 2, 3. We travel a little bit further to the left, and we wind up at -8. So if you add a negative number to another negative number, your answer is going to be even bigger negative number, or even smaller, depending. Like the digit itself is larger, but the further you go to the left, the smaller those numbers get. Okay, and example 3. Is -6 plus +6. So we do 0. Not far enough on that direction either. We start at 0, because we always do, and we're going to move 6 to the left because it's -6. And we're going to wind up over here. Draw the arrow that way. Go up a little bit. And then we're going to go 6 to the right because that's a positive. So we'll come back 6 to the right. When we go down, we see that our answer is 0. So a number plus its opposite, that's what that's called, equals 0. I would like to go over one of the practice problems. I'm going to just choose one. How about A? Letter A asks us to find each sum, illustrate problems A through D by sketching a number line, and E through H are done mentally. So A does need a number line. Please use a ruler. And if you have graph paper, that's even better. Some of you are running low by now. So A is -3 plus +4. So on the number line, make sure we number so I can see what you're doing. And start at 0, 3 to the left because it's -3. And then we move up, and then it's +4, so 4 to the right. 1, 2, 3, 4. And we head down, and our answer is 1. So -3 plus +4 is 1. We could do that with our little Legos we may have already. -3, +4, demonstrated this earlier. They pair up, and when they pair up, they go into the black hole. They just kind of go away. And we're left with +1.